Suppose the both are positively correlated, we say that both the variables move in the same direction. But if there is a negative correlation, we should understand that the variables move in different direction. What does negative correlation mean? When one value increases, the other value will decrease. The coefficient of correlation always lies between +1 and -1. So always you will get the values in decimals. You will never get a whole number in case of KARL Pearson's coefficient of correlation. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 3 of Unit 3, let us work out some more problems on KARL Pearson's coefficient of correlation, the shortcut method. Now, let us see what the problem is. So, given n equals 9, sigma xy is 3383, sigma x square is 3512, sigma y square is 3587. Calculate KARL Pearson's coefficient of correlation. So, the deviations are taken from the arithmetic mean. So, we know that arithmetic mean can be calculated in many ways. So, there is, you add all the values and divide it by the number of values, we get the mean. Then you also have the assumed mean method. You also have the deviations from the exact arithmetic mean. So, here the values are taken from the arithmetic mean. Deviations are taken from the arithmetic mean. Now, when deviations are taken from the arithmetic mean, we will be having this formula here. Sigma xy equals sigma x square, root of sigma x square into sigma y square. I just substitute the values. Now, instead of sigma xy, I write the value of sigma xy, 3383 divided by sigma x square, 3514. So, I am just substituting the values here. So, sigma y square equals 3587. So, 3383 divided by root of 1,26,04,718. So, the root of this is 3550.31. The answer is minus 0.99. So, this is the coefficient correlation. So, when it is negative, it means that there is a high degree of correlation between the variables. Then, next example is, so given sigma xy equals minus 26, sigma x square equals 20, sigma y square equals 40, n equals 6 pairs, what is R? Okay, so what is R here? Sigma xy by root of sigma x square into root of sigma y square. So, just substitute the values here. So, minus 26 divided by root of 20 into 40. So, minus 26 divided by 20 into 40 is 800. So, root of 800 is 28.8. Again, we have a high degree of correlation. So, there is negative correlation here. So, what does negative correlation mean? When one value increases, the other value will decrease. So, the answer is correlation equals minus 0.92. Now, next problem, given that deviations of x from the assumed mean sigma dx equals 96. The deviation of x square is 1128. Deviations of y from the assumed mean is 84. Deviation of y squared is 1380. Then product of deviations dx dy is 312. Pairs of observation is 12. Calculate the coefficient of correlation. So, here the deviations are taken from the assumed mean. So, we have to follow the shortcut method. So, we have to first write down the formula here. Now, the formula R equals sigma dx dy minus sigma dx into sigma dy divided by n whole over root of sigma dx square minus sigma dx the whole square divided by n into sigma dy square minus sigma dy the whole square divided by n. Now, R is given, what is the sigma dx into dy? It is given as 312. So I write here 312. So 312 minus 96 into 84. So sigma dx is 94, dy equals 84, n equals 12. So I have written 96 into 84 divided by 12 whole over root of 1128 minus 96 the whole square divided by 12 into 1380 minus 84 the whole square divided by 12. So this is equal to 312 minus, so 96 into 84. 96 into 84 will be 8064 divided by 12 whole over root of 1128 minus 9216 divided by 12 into 1380 minus 7056 divided by 12. So we have this. So when I just squared the numbers, so 96 the whole square, I get 9216, and when I squared 84 the whole square, I get 7056. Now I simplify this further. So 3112 minus 672 divided by root of 1128 minus 768 into 1380 minus 588. When I simplify this, that is 1128 minus 768, I get 360 into, I have simplified this, 1380 minus 588, I get 792. So when I simplify this, I get 2,85,120. Root of that is 533.97. So the correlation answer is 0.674195, or the correlation is minus 0.67. Now let us understand the properties of KARL Pearson's coefficient of correlation. The following are the important properties of KARL Pearson's coefficient of correlation. First one is, it is based on arithmetic mean and standard deviation. Second one is, the coefficient of correlation always lies between +1 and -1. So always you will get the values in decimals. You will never get a whole number in case of KARL Pearson's coefficient of correlation. Then, coefficient of correlation assesses both the direction as well as the degree of change. So, it will tell us both the variables move in the same direction or in the different direction. So, how do we know that? With the help of the symbol. Suppose the both are positively correlated, we say that both the variables move in the same direction. But if there is a negative correlation, we should understand that the variables move in different direction. So it is independent of the changes or variations of scale and origin of the variables x and y. So this KARL Pearson's coefficient, it is independent of the variations of scale and origin. Then it considers all the items of the variable. So every item of the variable is taken into consideration. It does not show or prove causation, but it is simply a calculation of covariation. So it is a geometric mean of two regression coefficients, that is R equals root of bxy into byx. Under this method, the coefficient of correlation is independent of the unit of measurement. So whatever be the measurement, we can always calculate the coefficient. So it can be measured between two unrelated variables and such numbers can be misleading. Such correlation is called accidental correlation. Then the correlation coefficient is symmetrical with respect to x and y. So whether it is r into xy or r into yx, both are the same. Then coefficient correlation is a pure number. It does not depend upon the units of the variables which are a measure. Next one is the merits of KARL-Pearson's coefficient of correlation. So it takes into account all items of values of the variable. So it is an important thing because it is taking into consideration all the values. Then it is a numerical assessment and hence more objective. So this method calculates both direction as well as degree of change. So we also know the direction as well as to what extent there is a positive correlation or a negative correlation between the variables, and if a pure number independent of a units. Hence, it provides comparison between the two series. So, there is a comparison between the two series. So, we find that these are the merits of KARL-Pearson's coefficient of correlation. Then, next one is what are the demerits? First one is it is not easy to measure as a complex formulae are involved. So, when we are writing the formula for coefficient of correlation, the formula is too huge. We have to write sigma dx dy into sigma dx minus sigma dy divided by n whole over, again, root of sigma dx square minus sigma dx the whole square divided by n into sigma dy square minus sigma dy the whole square divided by n. Second one is it is very difficult to interpret the significance of correlation of two variables. Once we get the answer for the coefficient of correlation, it is very difficult to interpret it, the significance of the correlation. Third one is it assumes a linear relationship between variables, which is not correct. So, this KARL-Pearson's coefficient, it just tells us that there is a linear relationship whenever there are two sets of variables, which is not always correct. So, this method consumes more time for compared to other methods like rank correlation. So, while calculating the correlation in KARL-Pearson's method, this is more time consuming as compared to the rank correlation method. So, then we have an example here. The following results are obtained between two factories from the respective means. Calculate correlation coefficient. So, in factory A, the number of observations is 5. Factory B also, the number of observations is 5. Then, they have given us the mean here. So, factory A it is 4, factory B it is 8. The sum of the squares of deviations from the mean is 28 and 76. The summation of the products of deviation of x and y from the respective means is 46. Now, we have the given values here. So, the given values are n equals 7, mean equals 4, mean of y equals 8, sigma x square is 28, sigma y square is 70. Now, we have to apply the formula here. So, what is the formula here? Sigma xy divided by, this is sigma xy divided by root of sigma x square into sigma y square. So, this is the formula. So, I just have to just substitute the values here. So, sigma xy is 46. So, the root of sigma x square is 28, sigma y square is 70. 46 divided by root of 2128, 46 divided by 46.13, we get the answer as 0.99. Now, there is one more example. If the covariance between x and y variable is 10 and the variable of x and y are 64 and 81, find the coefficient of correlation. So, we have a problem here. So, what are the values given here? They have given the covariance of x and y. So, the covariance of x and y is 10 and the variance means standard deviation the whole square. So, standard deviation the whole square of x is 64 and standard deviation the whole square of y equals 81. Find the coefficient of correlation. So, we have the covariance of x and y divided by standard deviation of x into standard deviation y. So, this will be equal to 10 divided by, now the variance, that is the standard deviation, the whole square equals 64. So, the variance of x will be root of 64 and the variance of y equals root of 81. So, the root of 64 is 8, the root of 81 is 9. So, I need the variance of x. So, the variance of x is 8. Variance of y is 9. So, this will be equal to 10 divided by 72. So, this will be equal to 0.1388. So, this is the correlation coefficient. So, very simple. They have given us the covariance here. So, they have also given us the variance. So, what is variance? Variance is nothing but standard deviation the whole square. So, the standard deviation the whole square of x is 64, y is 81. So, I just substituted the values. I got the answer as 0.1388. So, this is the correlation coefficient. The next concept we have to study is the probable error. The probable error is a measure used to find the extent of dependability or reliability of a sample correlation coefficient. So, the probable error of coefficient correlation is usually denoted by PE, and we have this symbol here. So, it tells us the limits within which the values of P of the various samples taken from the same group or of the entire group will vary. So, it means that different samples are drawn of a population, or even if the entire population is considered, the correlation values will lie between the probable error of correlation coefficient. The probable error of the correlation coefficient is given by PE equals 0.6745 into 1 minus correlation the whole square divided by root of n. So, this is one formula which we should make a note of. So, the probable error. What is this concept of probable error? It is used to find the extent of dependability or reliability of a sample correlation coefficient. So, how far you can rely on that particular sample. So, the probable error of correlation coefficient may be used to determine the limits of the population coefficient correlation. So, with the help of probable error, we will be able to determine the limits within which the correlation coefficient which is expected to lie. Therefore, the population coefficient correlation limits are given by the probable error plus or minus the PE value. It also implies that even if we take another random sample or samples the same size from the same population, then the observed values of the correlation coefficients are expected to lie within the limits. So, PE is used to know the reliability or significance of the observed values. Example of P equals 0.8 and n equals 64. What is the probable error? What are the limits of the population of correlation? So, I have the formula here. So, 1 minus 0.6745 into 1 minus the p square divided by root of n. So, 0.67451 minus 1 minus 0.8 the whole square divided by root 64. So, I just substituted the values here. So, 0.8 the whole square will be 0.64 divided by 8. So, 0.6745 into 0.36 divided by 8. So, this will come up to 0.303525, or probable error is 0.03. So, the limits for the population correlation coefficient is P plus or minus PE. So this will be equal to 0.80 minus 0.03, that is 0.77, and when you add this, I get 0.83. Therefore, population P will lie between 0.77 and 0.83. So this is how we will have to calculate the probable error. With this, we come to the end of this session. Hope you have all followed it. Thank you.